Hello, my fourth graders, welcome. This is our new chapter, chapter 14, Identify Symmetry and Two-Dimensional Shapes. Let's take a look at our target. Understand symmetry and two-dimensional shapes. And criteria is that I can define symmetry and describe two-dimensional shapes, compare angles and shapes, draw different angles and shapes. These are the review words that we need to work on and review. Hexagon, 6, right? Octagon, 8. Quadrilateral is 4 sides. Triangle, 3. Okay, keep that in your mind. And it has what? 3 angles and 3 sides. So this is triangles. And next, it's what? 1, 2, 3, 4 sides and 4 angles. That's, yes, quadrilateral. And the other one, 1, 2, 3, 4, 5, 6 shapes. Okay, I mean 6 sides and 6 angles. We call it hexagon. The other one, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Octagon. Okay, let's move on. Use your vocabulary cards to match the word to a shape. Number 1, equatorial triangle. Equatorial, equal. Equal is what? All together, all the same, right? So 3 sides are all equal. That's equatorial. Okay. And isosceles is what? Isolated. Isolated is what? One is different. Okay, one is a little bit isolated. That means what? It has 2 sides are equal, but one side is isolated. Okay, just remember the way. And right triangle, right angle, right triangle. You see that? Right angle, it has 1 at least, right? I mean, it has to be 1. You can have 2. All right. And scaling triangle is the angle, the side are not even equal, even 2 pairs. Okay, so all the sides are having different length. That's scaling triangle. Please have your vocabulary cards here, and I want you to practice, okay, at home. In our lesson 14.1, learning target. Identify shapes that have line symmetry. Okay, and I can define whether a shape has line symmetry or identify how many lines of symmetry a shape has. Draw each line of symmetry a shape has. That's the things that we are going to take a look. All right, so it's gonna be another easy lesson, continued from 3rd grade. Okay, it's not something new for you. So let's go ahead. How many ways can you fold the letter X so that the 2 parts match exactly? That means what? 2 parts match exactly. That's lines of symmetry. Okay, so we are going to find out the lines of symmetry. Okay, so draw models to support your answer. Okay, now think, if you fold this way, yes, you are going to have these 2 sides are going to meet and the other sides are going to meet, right? And if you fold this way, yes, these 2 sides are going to meet and these 2 sides are going to meet exactly. Okay, match. All right. Now, what other letters can you fold so that the 2 parts match exactly? Draw models to support your answer. Compare your answers with a partner. I want you to make your own list, and when we are going over in the class, I can ask you guys, okay? All right, let's move on. A shape has line symmetry when it can be folded on a line so that 2 parts match exactly. 2 parts match exactly. If some part is not matching exactly, that's not the line symmetry. Okay, the fourth line itself, we call it what? Line of symmetry. So this line itself is what? Line of symmetry. But then a shape has line symmetry means what? If that shape has line symmetry or not. That means how many lines of symmetry you can find. Okay, 1 or 2 or even more. All right, let's take a look. Example, determine whether the shape has line symmetry. The shape can be folded so that two parts match exactly. So the shape has how many lines of symmetry in here? How many lines you see? How many lines of symmetry? You see that? 2 lines of symmetry. So the shape has or has not? Yes, has line symmetry. And this Descartes is thinking a line of symmetry divides a shape into two parts that are mirror images of each other, right? And I'm sure you watched the video before you start this lesson. Okay, lines of symmetry or symmetry line, line symmetry, you can call differently. Okay, so please watch it and remember mirror images of each other. So in the video, the boy was putting the mirror on his in between the eyes, right? Please remember that the mirror images of each other. Example, another one. Determine whether the shape has line symmetry. The shape cannot be folded so that two parts match exactly. Okay, so you see that? Can you find any, like if we fold this way or even that way? We are not going to be able to find any line of symmetry. That means what? The shape has not or no lines of symmetry. The has not have or no lines of symmetry. Okay, so the shape has no line symmetry. Now number 1, 2, 3, 4, 5, 6. Let's try to find out. Determine whether the line is a line of symmetry. Nope. This is the other side. There is nothing, right? No point. But if the line was here, yes, maybe. But this line is not the line symmetry, okay? You cannot find it. You cannot find any line of symmetry. But this one, yes. No explanation, right? You don't need it. So here, yes. And this one, determine whether the shape has line symmetry. Draw each line of symmetry. Maybe this arrow can be folded in here like that. And yes. This one, yeah, you can find 1, 2, 3, and 4, and 5. And this is what? Yes, this is pentagon and it has 5 lines of symmetry. So this is yes. What about L? Oh, you cannot find any. Not here, not there, not this, nothing. Okay, so no. Alright, let's move on. I want you to pause the video and then do it yourself. Okay, and then check your answers with my video when you're done. Alright, I'm gonna go a little bit faster and it seems like, what about here? No, this is shorter than this part is shorter than this is the bottom part. So this is no. And if I cut it in here, I mean fold it in here, it seems like it, yes. And what about if I tilt a little bit of line and then, yeah. And this has 1 or 2, right? So yes. And this one, yes. What about this one? If you cut it in here, this is going to become here, right? And this is going to be coming here. What if I what if I fold it in this way? But this is gonna come here, right? And this is gonna go that way. So no, I cannot find any. Okay, so the answer is what? No. Now number 13, create a 3-digit number that has a line of symmetry. All right, 0, maybe like here. Okay, so let's find out the numbers that has what? Numbers that have a line of symmetry. So this, yes, 0, 1, yes, of course. 2, no. 3, yes, when you fold in, right? 4, no. 5, no. 6, 7, 8, maybe, yes. Like snowman, right? and 9. So now you need to create a 3-digit number. Maybe I can say 130, 103, or 180, or 183. No, you can make more, okay? Alright, so number 14. How can you tell when a line is not a line of symmetry? Do you remember what Descartes says? A line of symmetry divides a shape into two parts that are mirror images of each other. You can explain like that what Descartes says, okay? So if the line does not divide the shape into two parts, um, and that are mirror images of each other. Two parts that are mirror images of each other. So if the line does not divide the shape into two parts that are mirror images of each other, if it's not, that is not a line of symmetry. Okay? Alright, now number 15. Draw 4 lines of symmetry for the circle. Can you draw more lines of symmetry? Example. So if I cut it into half and half, okay, 4 lines, maybe we can cut more. Oh, this is like pizza, right? And can you draw more lines of symmetry? Yes. For the circle, as long as the line is passing through the center, like middle, yes, that is what? Line of symmetry. When a line passes through the center, that is a line of symmetry. So as long as that line passed through the center, you can create, let me say, countless, okay? Because you cannot count how many lines of symmetry you can find from the circle, because as long as when you see through the microscope, then maybe you can still draw more lines, okay? All right. Last page, guys. Example, divide the archery target into multiple sections using each of its lines of symmetry. An archer gets 2 arrows in each section. How many arrows does the archer get on the target? Draw each line of symmetry on the target. So they drew this one in here. So how many lines of symmetry? 1, 2, 3, 4. Okay, the target has how many lines of symmetry? 4 lines of symmetry. Now count the sections. 1, 2, 3, 4, 5, 6, 7, and 8. The lines of symmetry divide the target into 8 sections. So the archer gets 2 arrows in each section, so multiply the number of sections by 2. 8 sections by 2, which is 16. Okay, so the archer gets what? 16 arrows on the target. Now let's do show and grow. Divide the soccer field into multiple sections using each of its lines of symmetry. At the start of the game, there are 3 players in each section. How many players are on the field? So let's find out the lines of symmetry first. You cannot cut it and fold it into diagonal, right? This is rectangle. If the square is possible, but it's not. 1 and 2. That's all I can think of, right? And if there are 3 players are in each section, then 3 times 4. How many players? 12 players. Alright, number 17. Your friend folds a rectangular sheet of paper in half horizontally and then in half again vertically. She then draws the shape shown on the folded paper, cut it out, and then unfolds it. How many lines of symmetry does your friend's cut out have? Explain. I want you to try, okay, by yourself. So you have, to be honest, it has 1, 2, 3, 4, 4 sides, okay, and each side has what? 1, 2, 3, okay. I want you to try by yourself, and it goes right by yourself, and share it with me later, okay, during the class. All right. I will see you guys in a few minutes, and if you are done, please do I excel. Okay, bye bye.